Okay. Good morning, friends. Let's start. Uh, Let me share the presentation. So, is it visible? Is the presentation visible?
Yes, sir.
Okay. So, we have been talking about design patterns, and we have used some of these design patterns already. So, a design pattern, as we have seen, is a recurring solution to a recurring problem, right? This is the critical thing, and it describes a problem and then describes a solution which is sufficiently generic so that it is applicable in a wide variety of contexts. It is different from being a specific solution like an algorithm or an idiom, but it is kind of a repetitive design solution that we are talking about here. And in terms of the describing the design pattern, there is a specific format which was proposed by Gang of Four and is widely accepted everywhere. Now, there are certain essential elements like the name of the pattern, the problem that it attempts to solve, and the elements that make up its solution, the relationship between the elements, the responsibilities, collaboration, and so on, and the consequences. And based on this, we have actually discussed about the iterative pattern. Let me just go to that slide. So this is what we have seen. This is the crux of a design pattern, that what kind of pattern it is. It is an iterator, and it's a kind of a behavioral pattern which tries to provide access to elements of an aggregate or a container sequentially without exposing the underlying representation. So for this, we have seen the iterator pattern, and you have been without the formal knowledge about this pattern, you have been using it quite extensively, I'm sure, in terms of using the STL components. Now, I'll skip over the following slides, which we have discussed already. Let us go to the total set of design patterns. So we saw that there is a catalog of design patterns which are widely available and uh, widely used in software design, that was proposed by Gang of Four, and they are grouped in terms of their nature, the purpose. There are creational patterns, of which singleton you have already seen, so we would not discuss. We have understood and used singleton quite extensively. There are structural patterns, and there are behavioral patterns, of which also we have seen the iterator. And in yesterday's class, we have talked about the command pattern, where you have to provide a command to an executor, and how you can dissociate the creation of the command and its queuing or kind of maintaining it for waiting for execution, and then actually delegate it to an executor in a very generic form. We have seen that command pattern, which actually use in C++, it use the concept of functors heavily. So these are the different kinds of purposes, and in terms of scope, we have seen that there are majority of the patterns deal with properties of objects like the singleton, iterator, or command, but there are some which are concerned about the construction of the classes or the properties of the classes. The patterns are interrelated in various different ways. That is, the visualization of one pattern is dependent on the definition of other patterns. Right. So this is what we have done yesterday. So far we can say that we have understood three different patterns. One is singleton, which is a creational pattern for objects. One is iterator, which is a behavioral pattern for objects, and also the command pattern, which is behavioral also for objects. Today we will talk about two other patterns that typically are very useful. Okay? So I have a different presentation for that. So I'll stop sharing on this and pull up that presentation. Is this presentation visible?
Yes, sir.
Okay. So next we will talk about two patterns. One is a visitor and other is a factory method, which are very, very useful and very commonly used. In fact, you have already needed both of them in your booking assignment, though you may not have used it because you did not have the knowledge for it. You have done a specific design and implementation in your own way. And in terms of describing these patterns, I will not get into the details of the design pattern format and generic the way to specify all details and all that. I have cut down on those details. I just want to focus on the specific aspects of the pattern through illustrative examples so that you can quickly get an idea. So let's first talk about visitor pattern. Now, the context of the visitor pattern is, let us consider that there is a class hierarchy whose functionality we want to enhance. Right? This is very typical. I mean, you create a class hierarchy, and one of the basic objectives of class hierarchy, or the property of class hierarchy in object-oriented programming, is that it can be easily extended without recompiling major parts of your project. So to do this, what do we want to do? What we might want to do? One is we want to add new classes. So we know that the way the language is designed, it is designed to facilitate this. So it is very easy to add a new class, derive it from a leaf class, and implement the needed virtual functions. Right? You do not need to change or recompile any of the existing classes. So you have a very good code reuse at its place. Now let us consider another situation which also keeps on happening, is that we want to add a new virtual member function. We want to add a new virtual member function to the hierarchy, right? Now this, you can see, is difficult, because if we have to add a new virtual member function, then we must add that virtual member function to the root class, right? Because we invoke them through pointers reference to the root class object, right? Basically, the upcast of the actual concrete class in terms of the root class. So we must add that virtual member function to the root class, and possibly to many other classes in the hierarchy who would need to override that member function. For example, specifically, if the virtual member function is a pure one, I'm sorry, if it is a pure one, then all those classes which are concrete on the hierarchy will need to provide an implementation. So this is a major operation, and it modifies the root class on which the entire hierarchy and the clients are dependent. So which means that you basically have to recompile everything. You recompile all the classes, your entire library, and the client codes which are dependent on that library. So the summary is it is easy to add a new class, but it is very difficult to add new virtual member functions. So to basically see this situation through an example, we consider a document editor, which let's say deals with document elements. Document editor like say Word, which deals with document elements such that paragraphs, vector drawings, bitmaps that are represented as classes derived from a common root, say document element, right? So a document has these different elements. It has paragraphs, vector drawings, bitmaps, and so on. So the document is a structured collection of pointers to document element. This will sound very similar to the shape class we had discussed earlier, like for a drawing. So you have different elements, and finally your document is a structured collection of these elements. So it is a collection of pointers to these elements. And a common requirement would be to iterate through this structure and perform different operations, such as in Word we do spell checking, we might do reformatting, we want to change the font for all elements, we want to change the text weight or the document weight and so on. We want to gather various statistics of how many words, how many blanks, and so on and so forth. So ideally what we'll do, we should implement these operations mostly by adding code. Not by modifying the existing code. We should add code which can help us do this, right? Because that is certainly more maintainable. And for the ease of maintenance, if we can put all the code pertaining to say one purpose of operation together, then it will be certainly a lot more maintainable, right? So for example, if we have to gather statistics, then if we can put all of that into one class, it will be much easier to manage than if it is distributed across different document elements. So let's talk about the specific example of statistics. So the document statistics may include, say, number of characters, non-blank characters, words, images, and so on. And we will construct a class called, say, docstats, which maintains these statistics. So let's see how the design looks like. So these are not complete codes. These are snippets, just highlighting the part that we are concerned with. So we have a docstats class, which has members to keep number of characters, non-blank characters, words, images, etc. And we have methods like add characters. That is, if a particular document element has 5 characters, we should be able to add that number to the number of characters already found. Similarly, there will be add word, add image, and there'll be a method to display the statistics to the user. Now, what will doc element has to do? For every doc element, it has to update the statistics, right? So I have a update statistics, which takes the docstats object and updates the statistics for itself. So naturally, at a generic doc element level, I do not know how to implement it. So it is a pure virtual function. Now we have a paragraph, which is a specialization of doc element. We have raster bitmap, which is a specialization of doc element, and so on. So How does paragraph implement this? Paragraph has to implement update stats by invoking the add cats of statistics. Statistics have add cats, so it invokes add cats, and the paragraph knows how many characters it has, and it passes that as a parameter. Similar thing can be done for add words and so on. Similarly, for a rastered bitmap doc element, it will also implement update stats, and all that it need to do is invoke the add image of the statistics with a number 1, because there is only one image in a bitmap. Naturally, there's nothing else like characters or words, so those will not be updated. And finally, the display statistics will be an iteration over the elements to update the call update statistics for each element of the doc element. So you iterate over the collection of doc elements and do update statistics, and then you can display that. So this is the basic scheme which we can very clearly and quickly design. Now, there are a lot of lacunae in this. One, it requires doc element and its derives, that is paragraph, raster, bitmap, to have access to the docstat definition. So if you at some point modify the docstats class for some reason, then you will have to recompile the entire doc elements hierarchy. So there is a very strong coupling, as we say, between the docstats and the doc element. And the actual operation of gathering statistics, so we wanted that it should be concentrated at one point so that it becomes easy to maintain and debug, but it is actually spread through the different update stats implementation of different doc elements. So someone who has to maintain this will have to search and edit multiple files to be able to do that, build that, and so on. So it also does not scale with respect to adding similar operations like we are doing. We have shown this for statistics. Now, suppose if we have to do a similar operation like increment font size by 1 point, this will not scale directly because we will need to add a new virtual function to the doc elements, and that virtual function will have to be implemented in all the doc element derived classes. So these are kind of the lacunae in terms of the design that we have done for this purpose. Now, so if we have to work away from this and improve the design, we have to break the dependency between doc elements and doc statistics, and move all operations into doc statistics class. And we need to figure out what to do for each concrete type. So this implies that now doc statistics should have a member function, say like update statistics, which take a doc element object. We are just reverting the way we look at it. Earlier, I go to slide 5. Earlier, every doc element has an update stat, which was taking the statistics object. Now, every docstats, the docstats now has an update stat which takes a doc element as an object, as a parameter. So the document simply iterates through the elements and call the update stat for each of them. This solution will mean that since we are moving the update stat into the doc stats, it will mean that it becomes invisible to doc element. It will become independent. But now the doc stat will depend on each concrete doc element it needs to proceed, right? Because it has to call, it has to provide an update stat logic for every doc element type. Now, this is more acceptable because if we will usually have hierarchies which are more stable than its operations, right? If we have the operations more stable than the hierarchy, then the earlier solution is quite okay. But More often, the object hierarchy usually does not change, but the functionality keeps on coming up. So it is okay that docstat will depend on each concrete doc element. That is, it will depend on the doc element hierarchy. But the problem is that the implementation of the update stats now has to rely on a type switch. For example, just look at the code below. We are trying to do update stat, and it gets a doc element, which is the root object. So it does not know which logic to apply. So what it will have to do, I mean, you will say that this is what is possible, is at the runtime, I can find out which type of object it is. We know how to do that using dynamic cast. We are doing a downcast here. We take the address of the element and do a dynamic cast, and to try to do it to a paragraph pointer. If it is not null, this is what we'll check. Then you do the update statistics from paragraph. If it is for a raster bitmap, you update statistics for the images and so on. So you will have a kind of a if switch again, because it has to delegate the operations of update stat based on the doc element type. So, but we do not, so we need to add new functions. And now, how do we get rid of this type switch? You know that we do not like type switch in object-oriented programming. It is one of the strongest principle, right? So one way we can get rid of this is what we had seen before, is we have a hierarchy. Now, I mean, instead of having this type switch, we can have separate virtual function for each, right? But then again, it becomes a difficulty because we will have to add the virtual function in terms of the doc elements. So we use a new concept. What we do is we implement what is known as a unique bouncing virtual function in the doc element hierarchy that will kind of teleport the work to a different hierarchy. So we have two hierarchies. One is what we will call what is the doc element hierarchy, what we want to visit, where we want to extract properties from. And we will have a hierarchy of operations. That is, hierarchy of operations is computing statistics for paragraph, for bitmap, and so on, and which we'll call is a visitor hierarchy. I know this is sounding little cryptic, so let's get to the example. So we define an abstract class doc element visitor, right? So which defines an operation for each type of object in the doc element hierarchy. So this is different from the doc stats. It is different from the doc element. It is just a visitor class. So its purpose is to kind of abstract the different operations that we want to do, or the operations that we want to do on different doc element types. So we say that a visit paragraph is a visitor for paragraphs. Then there is a visitor for raster maps and so on. Now, how will this connect these two? I mean, this hierarchy of doc element and the doc stats class. So we add what is known as a bouncing function called accept to the doc elements hierarchy that takes the visitor as a parameter and invokes the corresponding virtual member function. So just see, this is the way this is done. So in doc element, we have one accept virtual function pure, which takes a doc element visitor. So what you want is for paragraph, I should be able to invoke visit paragraph. For bitmap, raster bitmap, I should be able to invoke visit raster bitmap. So accept does that. It takes a doc element visitor. It does not know what that visitor do, but it takes the doc element visitor and it invokes a corresponding virtual function, passing itself, because I need that doc element object, passing itself as a parameter. So it takes the doc element visitor and does that. So this basically is taking the operation from one hierarchy to the other, right? You wanted to do it on the hierarchy of doc elements, so where you have paragraphs and raster bitmap and so on, and you are taking it to the hierarchy of visitors, the different operations in the visitor, right? And so whatever the actual implemented visitor is, this will fall in that visitor, and that corresponding virtual function will get called. So now docstats is derived from the element doc element visitor, right? So it is a visitor now, right? So it comes in the hierarchy of visitor, and it implements the visit paragraph. So now this is how these are. You can see that visit paragraph, visit raster bitmap are the pieces of switch code, type switch code that we had. Now we put this into all these different virtual functions. So this way we can separate the two hierarchies, and the way we will use is very simple. That document will have a display statistics, which makes a statistics object, and it is a specialization of the doc element visitor, and the document iterates over doc elements in the document, and for every element it will call accept statistics. You can see accept is a virtual pure virtual member function in doc element. So every doc element has to implement accept, which does the bouncing of whatever accept is called. It is bounced to the corresponding virtual function in the element visitor hierarchy, right? In this case, it will be bounced to the accept will bounce for paragraph, will bounce to the visitor paragraph of the statistics. It will bounce to this visit paragraph of the statistics. Similarly, for raster bitmap, the similar things will happen. So now you can see that it is very interesting that the computations of statistics on the doc elements are being done by the docstats object in docstats class, and the docstat class does not need to know the details of the doc element hierarchy. Doc element hierarchy does not need to know the details of the statistics class. The doc element visitor is actually achieving this new hierarchy, which is called the visitor hierarchy, which is a hierarchy of operations which will actually achieve this connection and provide us a isolated, very nice solution. So no element to the of the doc element hierarchy needs to be changed any further if you make changes to the statistics, because you are deriving it from the doc element visitor, which does not itself change. So we can, for example, we can add another new operation, say increment font size. So all that we'll need to do is to specialize it from the doc element visitor and implement all the functions, virtual member functions that are there in the doc element visitor for different doc elements type. So if you change the doc element hierarchy, then all that will need to change is in terms of the doc element visitor. And for example, here you are changing the font size. So visit paragraph changes the font size by calling the set font size method interface of the paragraph. Similarly, for visit raster map, there is nothing to do. It's a kind of an empty function, because font size change has no effect on the raster bitmap. So this is kind of the UML diagram for it, which must be clear to you. So I have a doc element visitor, I have doc stats here, I have increment font size here, and I have a doc element hierarchy, which is paragraph and raster bitmap. And it is this accept that connects, that bounces the requirement in the visited hierarchy to the visitor hierarchy. This is the more generic UML diagram that you will find in the books on design pattern. And this is the sequence diagram for it. I will not go through the details, but let me stop for a while and see if you have any questions. This is a very, very powerful, very, very useful mechanism, which you can use at any point of time. Wherever you have a stable hierarchy. So the basic use model is your hierarchy on which you want to do these computations should be moderately stable. If that hierarchy is not stable, you need recompilations anyway. So doing this kind of thing will may not really help. It does, because it kind of does a separation of concerns, that is the operations that are independent of the doc element, like the statistics or the font size change, can be taken out and clubbed together, but it has less effectiveness. But on more stable hierarchies, you can use the visitor pattern to flexibly add operations as and when you need. Okay.
Sir, in the example that Bootstrap uses for visitors, why does he use the double dispatch trick? Like,
This is double dispatch.
yeah, but he writes it in a very different way. I need to actually edit the hierarchy, so that kind of defeats the purpose of the visitor entirely.
Right, because Strauss-Stroop is such a high level thinker that he finds it very difficult to come down to our level. I mean, I put it that way. I mean, Strauss-Stroop's book I recommend as a first text, of course, because there is no other option. But he does not write it in a lucid way that it should be expressed. So all that you saw is from the modern C++ design book by Andrei Andreescu, who does it through examples very subtly and very explicitly. But if you are asking that, I mean, I did not write it here because I mean it's not the terminology that I mean. I can write it here also, but it's a double dispatch because you have one based on the accept. Which accept are you calling? So that is one dispatch, and then accept is again deciding based on the visitor hierarchy. So that's the second dispatch. So the double dispatch is required so that you are teleporting the runtime flexibility of calls from one hierarchy to the other. So as a mechanism, this is called double dispatch, but I would not recommend trying to go deeply with Strauss-Stroop's discussion, and I mean, at least I find it little mentally heavy and confusing.
Because like, no, I've written visitors for both C++ and Java, and visitors don't like the way I wrote the visitor did not require the way Bootstrap. It matches the way you wrote it, so that's why I
Yes.
got a little confused.
Yes. That's. I mean, I have naturally. That is. I'm not discovering any of this. I read and can various different sites and books and see what gives a very useful definition. Right. These 5 slides. I mean, even those who have not really gone through this 5 slides you read, you try to. You just think that what is your hierarchy, what are your operations. You just map this code there, it will work. And that kind of thing is what we need to learn. And the Strauss-Stroop does it I mean often gets into the designer's mindset, and he has to make everything sound perfectly correct because he's the originator, creator. That's, I mean, it I mean, I'm too small to dare to criticize him, and I would not. But the problem is, for a general developer programmer, that much of rigor in terms of language and features become difficult as a developer to keep reminding yourself of, unless you are someone like Strauss-Stroop. But you read Scott Myers, you read Herb Sutter, you read Andrei Andreescu.
More approachable.
These are people who are actually at the end of the day. Strauss-Stroop does a great job for engineering in the industry, but Strauss-Stroop is not an engineer. He's a professor like us, right? So his focus is always on the rigor. He will not
Academic.
be able to say a single word which may be construed to be partly wrong. Andre Andreescu rampantly says that this is what Stroustrup says. I mean, forget it. I mean, not so much of rigor. Let's see what happens on ground. And that is what engineers need. So you need to, I mean, someone who is really trying to master need to read both and understand in their own ways. Okay, so let's quickly get back and do a quick discussion on the factory uh, because we are left with very little time. So I hope the slide is visible. It's a factory is basically about what people paradoxically call virtual constructors. The basic point is in a class we can have all member functions as virtual. In a polymorphic object, all member functions can be virtual, including the destructor, except for the constructor, which is always a static function. Okay. So it has to be, because there is a lot of difference between creation and use. Right. So therefore, this is if we have a hierarchy like this, if you look at this example, the derived and other derived and so on. So this is how it will look like. So new takes derived as a parameter, which is when the class is getting constructed. Now this derived is a type name parameter, right? And therefore it is not like an object, right? So you cannot do this at the, I mean, you cannot change this at the runtime, right? So this means that if I want to add objects classes uh, and do not want to compile the code again, or I want to add objects at the classes at the runtime, we are not able to do that, right? So because virtual member functions are dynamic, they can change the behavior without changing the call side. They all look same, their behaviors are different, but they bind to the interface only. But the object creation does not work that way, because it binds to the type. And there is only one way to specify that type in C++. So the virtual constructor is an utopia. So given that, the question is, can we have a closed solution for that, which can kind of try to solve this problem? So the idea is, I mean, would you be able to provide some kind of an ID for the class, say as an integer constant 1 2 3 4, or a string like derived, and get the class constructed, the derived class constructed for that? So for this, the first task required is we cannot use new ever in that way. So you'll get a freedom from new. That is not difficult to get, because what you can do is we can introduce a pure virtual member function called say create document. In a document manager, we do a create document, and the purpose of that create document, it is a pure virtual function. So the purpose of that create document would be, when you implement it, you will implement it for a particular class, and you will do a new on that class. So that's so the first thing you want is a separation from your actual call to new in your code, so that can be relegated to within a pure virtual within a virtual function. But the question remains is how you basically get to call the right virtual function. So this create document that is encapsulating new in terms of a virtual function is known as it's called the factory method. The GOF book called it the factory method, and that term has got kind of accepted, right? So if we have to create a particular graphic document manager for this, so we have specialized from document manager, we'll implement create document by new graphic document. So at least we can abstract in terms of the create document factory method. Now, so what is the core issue? If you look at this, specific object creation in terms of derived, you can see that the basic problem is derived is a class name, whereas what we are asking for is we are asking for a value that is an object. So this is a comparison of classes and objects, which you all know, but I mean, just to highlight that classes are what programmers create. Objects are created by the program. You cannot create a new class at runtime. That is C++. You cannot create an object at compile time. Again, C++. Classes are creating only during compile time. Objects are created only at runtime. There's a complete separation. And most importantly, the classes don't have a first class status. That is, you cannot copy a class, you cannot store it in a variable, or you cannot return it in a function. Typical things that you can do with objects which are first class, which have the first class status. Right. So maybe you can visualize this kind of a code, that if it were possible to create new classes and runtime, copy it as a store, possibly you will have, I mean, written in C++ notation, but this certainly is not C++. Suppose you have a class, you can see that I'm writing this class with a capital C, meaning that that is something special. That is something special, which kind of has a structure which tells you that this is a class. So I want to do that. For that, I mean, I want to read a file name and get a class. So I'm saying that I'll provide within quotes derived, and we'll get the derived class. So if I have to open a document in the document manager, then I will pass a file name. And so from that file, I will read the name of the class. So that is what the read is doing. And this read will actually give me a name of a type. Right? This is where the catch lies. That this returns, this class is a type of types. It returns me a name of a type on which I can do a new. So that's, if we could do this, then well, it would have been very happy. I mean, this needs, I mean, goes into deeper stuff, like in object orientation, there's a property of reflection. C++ does not have reflection. Languages like Java, Python has that, so they can do this kind of things. Of course, they do it in a different way, but this is in a completely statically typed language, this is not possible to do that, because you need to know all the types at the compile time. So let's see what could be a solution around. So we are back to the shape example. So we have a abstract class shape which has multiple operations like draw, rotate, zoom, so that a drawing which is a collection of shapes can make use of this. So shapes will be specialized in terms of lines, circle, rectangle, and so on. And in drawing, you will maintain a collection, list or vector or tree of such pointers to such specialized object types of shape. So in now the question is obviously two basic things that you will need to do, and I'm focusing only on these two because these are often neglected aspects because of it gets difficult to provide a solution. So one is how do you save a drawing file? That is, how do you serialize? You have the object, the whole drawing in your system. Now you will need to close the application. So you need to save it in a drawing file. So you'll have to write down the details of the object in terms of a file information, right? So similarly, when you start a system, you have an existing file and you need to, given that file, you would like to recreate the data structure in memory, which is load, which is deserialization. Right? So the class drawing will look something like this. It has a save, it has a load, and they take the respective IO stream objects to read or write. Now, what will drawing.save do? So how do you implement it? You will possibly write a header. Right? A header is required for several information, like you might write down which application is creating this, who is writing this, which date, and so on. But we will see that we will also write a unique ID type of the object that we are writing, starting to write here. That, and then what you do an iteration over the elements of the drawing. and for each element, each element knows itself, it knows the members and so on. So each element has a save, which saves to the out file, right? So this is a very clean solution. You take the collection, iterate over it, and exactly the way the iterator pattern is supposed to help you. So saving is not a big issue. And if you look at common textbooks on C++, you'll find this example widely available. But very interestingly, the books then say that other things can be done similarly. Doesn't talk about the load, the other side. So how to load a drawing from a previously saved file? Because the issue of load is when you are loading, you do not have the object create. You need to create that object in memory. And to be able to create the object, you need to know what is the class for which the object has to be created. And you do not know that class. That is written in your file. So how do you get to that? Right? So we make an assumption. We make an assumption that obviously God will not tell us. So we will write a unique identifier for every type of object. And before we deserialize or read an object from the file, the details of its element values and so on, we will first read this unique ID so that we know that it corresponds to such an object type. Right? So let's try to do this. We have a drawing type namespace. I'm just not cluttering the global, which has a set of constants, line, polygon, circle. These are IDs for the classes. Then what you do, you are iterating. You are going over the in file. You first read the drawing type, which is, you expect that before the object, the ID will happen. So that you read that ID. And then based on that ID, you have no other way than to make a switch. Whether if it's a line, you create a new line. If it's a polygon, you create a new polygon. And so this is how you map the IDs in onto the corresponding new functions, and you have you have these objects created, and then you can invoke for the current object. You can now, since you know the object, you can invoke the virtual function to read the details of the object from the file, and then you add it to the container, and your data structure will be fine. So if we assume that there is an ID, and then we can have such kind of a solution for loading the shapes from the file. Now, this solution would work in a specific case, but has several issues. First being that old issue of having a type switch, which is what we should not have. Every switch is based on a type tag. And also it collects the knowledge about all shape derived classes in the program in a single source file. It has to, because otherwise this switch cannot be written. So this becomes very hard to extend. If you have to add a new ellipse type, then you have to create the class itself. You have to add integral constant to that namespace. You have to write that constant when saving the Eclipse object, because that was not there. And in the switch, we'll have to add another switch level. Right? So this is what gets difficult. So the way we will solve this is what we saw in terms of the functor design, that we will split the switch in terms of different virtual functions. So we'll say that what conceptually every switch level is doing is it's creating a concrete shape and giving you a shape pointer. Right? So just think about this. So it is kind of the switch decides which of these functions is to be called. And that is a solution which is generic to, in your polymorphic hierarchy, that is what is virtual function table. So we can maintain a similar kind of table, which is called a registry. So what we will do is we will assume that we have a registry which maps the ID to the function pointer. So you have a function pointer, which is that piece of the code in switch, and your ID maps to the function pointer. Then you have a register shape, so that given the ID, you register is as if you registered that function in that table. And you have an unregistered to remove. Once you have that, then as soon as you know the ID, you don't need to do anything. You can just go through the map, get the function pointer, and call that function pointer. And that solves the entire problem. The specific function, specifics of a class can be seen here, create line. So finally, the create shape now becomes you find out what is the registry entry for the ID, and then you call the corresponding virtual function to create concrete shape. Right? If it's not there in the registry, you throw a runtime error. And finally, here I will not go through this. You can read it later on. So the solution that we create here works for the object factory, because now it is all dissociated. So you are registering. So if you want to have a new class Eclipse, you can have its own ID and register it. And in fact, if you go back here, we are suggesting using a map, not a vector, even though the index is int, because a map has the flexibility. So it need not be integer IDs. I could use strings. I could use any other. I could use a randomly generated number. I mean, Microsoft's COM for a long time, Microsoft's COM actually used that. It generated a random number, 128-bit random number, and used that as an ID. So a map will easily solve that. So you want to add a new class, you simply need to create your ID and the callback function, and just register it and go forward. So that is what will solve it for shape. If you now can this design into a template version, you will have a very nice code for your factory method, kind of your virtual constructor, which takes the product type, that is a shape. It takes the identifier type, which could be integer ID or string or something, and it takes the signature of the delegation function, or the creation function, which is simply a function pointer to this abstract type, and rest of this code is this much simple. So with this, we will close today. We are completely out of time. If there are quick questions, I can take, but we are already time. Okay, so there is no question. So let us close it today. Have a nice weekend. I think we'll meet for the last time in the class on 14th, where I would like to little bit conclude more on the design pattern and conclude on the course, talk about some of the other interesting things happening in software engineering. Okay, bye.